Hello, welcome to Developer Joy with Quarkus. My name is Roberto Cortez. I work for Red Hat, and the last few years I've been working on this really awesome project called Quarkus, which I want to show you in today's session. So, I don't know if you heard about Quarkus before or not. So usually when I'm on a live audience, I just ask this question and try to make out of the room from people that raise their hands. But let's just assume that you haven't heard about Quarkus before. And well, Quarkus is actually an open source stack that is tailored to write any kind of Java applications. Um, when Quarkus started, the main goal was to be able to run things as cloud native, microservices, of course, and target also applications that should be serverless. Now, while Quarkus was targeted for these use cases, we actually seen that developers are using Quarkus to develop any kind of applications. You can call it monoliths, command line applications, even running things on embeddable devices like Raspberry Pis. And one of the reasons for that is because Quarkus is so much lightweight that it is really perfect to run on devices that really have or don't have that much resources. Now, probably the first question that you may ask is, well, why Quarkus? Why another runtime? Why another stack? And to be able to answer that question, we need to go a little back into how the JVM works and talk on what we like to call the hidden truth about Java and containers, right? So every time you start a Java application, there's always going to be an overhead, something that you have to pay the price of starting that JVM. Usually you have classes that have to be loaded, and that may create some memory overhead, right? Now, what happens over here is a lot of the classes that are being loaded in JVM, they're not only your application classes, they're also related with the runtime, but you need those to be able to run. Now, if you think for this for a second, let's just say that you're running like a few nodes of your application. It can be like on bare metal or the cloud, doesn't really matter. But every time you're starting that Java application, you're gonna have to pay the exact same price all the time. Now, this is not much relevant when you're running things into bare metal maybe like 10 or 15 years ago. If you think for that for a second, well, you probably just go and buy this really expensive rack, and because things were so hard to set up and to purchase, you will just buy like this rack with a lot of resources. So you were not too much concerned about the resource consumption of your application. Now, I mean, still there were some concerns, but not as much as we have them today, right? One of the main reasons for that is when you're running things into the cloud, you're going to have to pay exactly the amount of CPU and memory that you're going to use. Now, things become way more relevant in that particular case. Also, the sheer amount of size and the amount of scaling that most applications require today is very different from 10 or 15 years ago, right? So luckily you may be working on this application or this company that requires like high scalability resources. I don't know, maybe you have to run your application 50 nodes, 100 nodes, right? And in that case, paying that cost is really not interesting because you're gonna have to pay that cost 100 times, or at least as many times as you run a node, right? So that's something that we want to change with Quarkus, and I'm going to tell you a little bit about it in the next couple of slides. Going forward, there's also this thing where there is this perception that Java and the Java runtimes, well, in this particular case, I just speak hotspot, they are somehow heavyweight compared to other runtimes that people also love to develop, like Node.js and Go. Now, no, don't take me wrong, I don't want to start here a debate about what's the best language, right? And these graphs are not up to scale, but the reality is you're able to run way more Node.js nodes or even Go in the same amount of resources compared to a traditional Java runtime. Now, I love Java. I've been developing Java for the last 20 years, and but I mean I also love Node and Go. That's not the point. But I still want to Java to be relevant, right? So we try to come up with something that allows Java to have a more similar behavior to other technologies. And Quarkus makes that promise that with the same amount of resources, you can fit way more Quarkus nodes that you will able to fit a traditional Java application. So that's one of the promises that we want to make with Quarkus. Now we know that coming up with all of these performance improvements, either on memory and CPU, while a lot of people may make decisions just based on performance, we know that's not only the case, right? So we also wanted to make Quarkus a really good developer friendly environment. So we come up with a few things, right? So one of the things that people really love is our what we call developer joy, right? So it is our live reloading feature, meaning that you can just start your app, start doing some code on your IDE, whatever tool you use, and you just go and hit whatever endpoint. If you're developing a REST endpoint, you could just hit it again, and Quarkus will auto reload everything for you, and you don't have to go for this lengthy process where you have to stop and start the application. So usually I usually also make this question, which is how much time does it take for you to restart the application? And usually some people say like, well, 15 seconds, 20 seconds, 40 seconds, right? Even more, right? So the idea here with Quarkus is you don't have to pay that price, and allows you to always be in the zone where you're developing, you're focused on what you're doing, right? I think we always can relate when we are, let's just say, making a change and then we have to restart something. We end up just shifting our focus to something else. Maybe we go to the web and start reading some article or looking some web page, and in the end we end up wasting way more time than the amount of time that the application actually required to start. No, but if you look a little bit, let's go a little bit with more detail about some of the what we call the supersonic subatomic Java, right? So a traditional native stack, and this is just a simple REST endpoint, we see that sometimes it takes like, I don't know, 130 meg, a little bit more. But Quarkus, we are able to have half of the size in this particular example. If you run Quarkus as native, we've seen things like a tenth of the size for this example as well. But if we pick up a more complete example, like a REST plus CRUD, so meaning a few REST endpoints, database, and a few other things. So the traditional stack, of course, as there's a memory increase, there's also memory increase into Quarkus. It's not half of the size anymore, but still relevant. It's 3/4, so 50 meg difference. But if you run it on native, there's still like a tenth of the size that you'll see on the memory usage of Quarkus, right? So even when running Quarkus on the JVM, you may think, well, 50 meg is not really relevant. And yes, that may be true if you're running like a single node or just a couple of nodes, but when you're running 20, 50, 100 nodes, that all of these are going to add up, and then it becomes way more relevant in that case. We can also look into the startup time, right? So as I mentioned earlier, we've seen, like, we know that people have really long startup times for their runtimes. Now with Quarkus, we also want to lower the runtime startup for your application. So usually what you've seen when you're running Quarkus on JVM mode, sometimes even less than a second to start, and in more complete examples, you'll see things like 2 seconds or 3 seconds, which it's really interesting in my opinion. Now, the cool thing about Quarkus is when you run it on native, you're going to see like sub-millisecond startup time ranging between 20, 30 to 40 milliseconds, right? Which is really impressive in my opinion. I know I'm a little bit biased, but this is really useful when you want to run things like serverless or even command line applications just using Java. Moving forward, we know that there is a trend that people want to, or developers want to write more reactive applications. But we also know that reactive is not really easy to write and not even easy to learn. So we try to come up with APIs that allow you to write reactive applications without making a big change between the imperative world and the reactive world. So in this particular case, you see a couple of code samples where you have the imperative version, then you have the reactive version, right? And the only difference is you just change a couple of annotations and a couple of APIs, but pretty much everything is very similar, right? So there is no really complicated API that you have to learn to be able to run or to write a reactive application with Quarkus. And you can pick which one you want to use. You can either go reactive or you can go imperative. And you can even do it in the same application. You choose. Now, the other thing that we also like to joke about is, well, Quarkus, the first version came in 2019. But we like to joke about that maybe probably you already have like 10 or even more years of experience with Quarkus. And the reason for this is, well, looking into all of these logos, I'm pretty sure you recognize a lot of these logos, right? So you see things like Kafka, Camel, Vertex, Hibernate, Flyway, OpenShift, Kubernetes, of course, but even Spring, right? Um, so Quarkus actually is tailored with all of these libraries in mind, and you can build a Quarkus application just using these APIs, meaning that you don't have to learn any new thing to just be productive from day one. Of course, Quarkus does introduce some of its own APIs to fill in some gaps, but in most situations, you can just get away with using the APIs from these standard, well, not standard, well, some of them are standards, but from these popular libraries that exist in the Java ecosystem and most developers love and enjoy. Okay, so this was like a quick introduction. I have a lot of demos prepared for you today, so let's see how that works. But before going to demos, I like to also explain to you how Quarkus works internally, at least at the conceptual level, so you can make sense on what I'm explaining here today, and actually be convinced that what we promise with Quarkus actually is true, and that you're able to achieve such numbers on both CPU time and memory time. Well, to figure that out, so remember, or at least you have to think on how a traditional framework or runtime starts, right? So usually what you have is, well, you have your code, you apply some build process, it can be like Maven or Gradle or something else, that generates like a jar file or a fetch jar or some other kind of binary, it doesn't really matter. And after that, you just pick that output and then you hand it over to the runtime. So the runtime, when it starts, is going to pick up that file, is going to unpack it, is going to just start analyzing what's over there, maybe loading some configurations, maybe it's going to do some class path scanning and find your application classes to start up services, it's going to build models. So there's a bunch of operations that are happening in that case. But if you think for this for a second, this is not really a good way to do things, right? At least in the cloud world. If you think on the example that I gave earlier, when you have multiple nodes starting up, the same operations are going to be executed on each node again and again and again. Every time you start the app, you're going to have the same operations being executed, right? And so this is just cloud time or cloud resources that you're wasting, because, I mean, you still need to do the initialization of everything to be able to be ready to serve your business needs. But while this is being done, while you're not really doing any business things for your customers. Now, what Quarkus tried to do over here was try to shift things around, meaning that everything that we are able to do during compilation time, we call it build time, we try to do. So really, really quick example is, think about for a second if you have an XML file. So you have to read the XML file. To read the XML file, you usually require like an XML parser or something like that. You pick up the file, read the XML, and then you're done. Well, what we do with Quarkus is, yes, we do the exact same operation, we do it in build time, because I mean, it's unlikely that the XML file from a configuration thing is going to change between you build the application, then you run it. So what we do is, yes, we read the XML file, we pick up the data from what we read, we serialize that data into Quarkus memory, and when you run Quarkus, then you don't read the XML file anymore. You already have the serializable data. That's the thing that we read to recreate the models that the application requires. So this has a couple of advantages. So one is, because we read that over build time or compilation time, that operation is not going to be repeated when you start the application on multiple nodes. The second thing is, we read XML, so we don't need XML parsers anymore. So we can just remove those dependencies from runtime. Now, you may be thinking, well, this is not much relevant because, I mean, the amount of savings that you're going to do by doing this is not really that big. That's true. But now if you think in a more broader term and apply the exact same principle to pretty much everything, all of the savings are going to pile up and are going to add up. So you end up with a really a lower memory footprint and less startup time, because there is less things for you to load on memory, and there is less operations for you to execute when you're starting the app. So as a summary over here is, as optimizations is, we move as much as time as possible to the build phase. This allows also to minimize the runtime dependencies. So remember the first couple of slides where we have to all of that things that we have to load on the JVM. So it means that there is less things to load on the JVM. We also maximize that code elimination by removing pieces of the app that we know that are not going to be executed. So that also slims things a little bit. And these optimizations are going to benefit both GraalVM and Hotspot. So I'm going to go into GraalVM in a bit. But GraalVM is the thing that also allows us to run things into native. Now this is just also a summary on a couple of examples on what happens on the framework when on a startup time. So parsing the configuration files, as I mentioned, class path scanning and classes scanning. So that usually is a heavy operation which requires a lot of I/O. So that takes a lot of time. So there's a bunch of things that happen. As benefits, I think that they're pretty evident, right? So you only do the work once, not at each start, right? Things like bootstrap classes and other things are not required anymore, so you can remove all of that. In the end, you're going to require less time to start and less memory to be used. One of the things we also do with Quarkus is we try to have as less reflection as possible and no dynamic proxying. And one of the reasons we do this is to be completely ready to build the app as native. So how are we able to do this? So let's go to native image. So maybe you heard about this thing called GraalVM or not. So GraalVM is a really interesting project. It came from Oracle Labs. It's a polyglot VM, so it's able to run things like Java, of course, and but not only Java, also it's able to run Ruby, Python, JavaScript, and a few other languages. But they also have this capability to pick up your application and build it completely as a native executable. When you have a native executable, well, that's not Java anymore. It's just something native. So if you build C applications in the past, it's a similar process what happens over here. So your application is built for the architecture that you want to run. So it may be like a Mac OS or a Unix or whatever. And then it runs native for that architecture. But to be able to build to native, there are certain requirements that you have to follow, right? And some of those are, well, things like dynamic class loading, they're not supported, right? Because you need to have this closed world assumption when you have an executable. So if you will support things like this, or even or other things like reflection or dynamic proxying, which are indeed supported, but you require a manual list of things that you need, instead of just building a native executable that requires that only contains what it requires, then you will have to build a native executable which pretty much contains all the JVM, all your libraries, because the native executable will never guess and will never know what is going to be required at each point, right? So that's why there are some restrictions on what you can use for native image. Now, you shouldn't be too much concerned about these things. So this mostly could be for Quarkus developers, or I mean for people that actually work on the Quarkus code, because we did all of this for you automatically. So when you're running or when you're building application code, you usually don't have to worry about these things. So we detect these for you and we fix them for you. Okay, so I think those were the slides that I want to show you. Now I want to go with some demos. I mean, slides are great, but what's greatest is actually being able to show what something that you're presenting can do. So let's keep the slide still, but I'm going to move to my terminal. And I hope this is big enough, I think so. And I have here like a Quarkus application. Let's go here to services, and there is something called number API. So if I go here to IntelliJ, let's put this into presentation mode, actually. Okay, so actually if I put it in presentation mode, my screen will just go away. So I'll just put it like that. So let's close all of this, and so here's a number resource. So the idea of this number API application is it generates a number which is supposed to be an ISBN to a book to feed into another service that's able to manage books, like create, update them, and read them, and so on. Now, you probably recognize some of this code. Maybe you wrote this code before, right? So there's also this other class, which is number API. So this is the interface with the open API stuff. But if you come over here to the sources, and I'll do like a find in files, and you search for Quarkus, well, you're not going to see. You'll see here, well, there is a Quarkus reference over there, but it's only on the package name, and that's the package that I created. So that's actually the package from from this particular example. So meaning that there are no Quarkus APIs that are being used on this application. Now let's come over here, and one of the things I'm going to do is I'm going to run Quarkus in development mode. So this is usually how you want to start Quarkus when you're developing an application, right? So this is what it's going to be able to do. It's going to give you the hot reloading features and a couple of other things. So that's how you do it. Now let's go here to my other terminal, and I'm going to say curl https localhost 8090. That's where I'm running. I think number / generate. And there you go. So those are the numbers that are being generated by the application. Now, one of the things I can do and come over here is I can just say, well, instead of saying generate number and calling that method, I'm just going to say hello like this. And I'm going to call curl again. Now you got hello. Now notice that I haven't done anything. I haven't stopped the server. I haven't restart anything. The only thing that I did was came to the IDE, changed some code. I went back to the terminal. I call curl again, and well, you got the what we call the live reloading feature, right? Well, you may tell me, well, this is a really, really simple change, right? Because you only change the string, so maybe there is something fishy going on over there. So I'm going to implement a proper hello method. I'm just going to copy what I already have over here. And let's copy the response. Let's say hello over there. And I'll call, it's not right. Okay. I'll put like the get over here and now say slash hello. So I think that's fine. Let's just remove all the exclamation points. Just make sure we call the right one. Or you can see the difference. And now we just go to terminal and I'll call hello. Let's see, maybe I forgot to change something. Well, it misses an override method over here, but I think that should not be required. But let's see, numbers hello. Oh, that's not working. Well, how's that? So, okay, so there you go. Not sure, maybe it was missing something over there on the compilation part. But now you see I added a completely new endpoint, and now, well, I just say hello Roberto, that's me, and there you go, right? So now I added a completely new endpoint. I didn't have to restart anything. Things just work out of the box. There was some glitch over there, not sure, maybe I messed something over there, but that's how it is supposed to work. So let me roll back this, and one of the things I'm going to do now, just clear this up, and let's go see. I think I have. I'm just going to do history, so I don't have to type the entire thing again. Oh, I probably don't have it over here. That's strange. So never mind. I'm just going to copy that command. I know about memory, but just as a little bit long command. No, what I'm doing over here is you notice I just type mvn verify Quarkus container image build equals true and Quarkus Kubernetes deploy equals true. So just adding those two properties is going to instruct Quarkus to, well, create the Docker image from the app and then deploy the Docker image into a Kubernetes cluster. In this particular case, it's a Kubernetes cluster that I'm running locally. So if we look over here, so now there's like some tests are running. So it generated the image, or still generating the image. And now it's going to run integration tests. Now also notice that integration tests are going to be executed against the Docker image that was built on the previous step, right? So now you have tests that are being executed against the thing that's actually going to be run, which I think it's also quite interesting. And so things are starting up. There you go. And it's done. So now I can go, let's clear that up and say qctl get pods. And I have one pod running. And I can say logs, right? And now you see there is Quarkus running over there on my Kubernetes cluster. So now what I'm going to do is I'm going to call Quarkus remote dev. So I guess that you may be guessing what Quarkus remote dev is going to do. So Quarkus remote dev is going to give you the exact same developer experience I showed you earlier, but now connected to Quarkus that's running on Kubernetes. So let's try that out. So if I call curl, well, hello doesn't exist anymore because if you remember, I reverted the code back, but generate should be there, right? And if I come here to my IDE and say hello, and call that one again, now you're going to get, oops, now you have hello. So things are a little bit slower because I'm recording this session So the recording software is just hogging all my resources. So the experience might not be like super great. But let's try it again that way. Didn't update yet. And there you go, right? So that's remote dev when you're running that on Kubernetes. So one of the interesting thing about having remote dev on a Kubernetes cluster is, well, we know there are companies that maybe have other services running on Kubernetes, maybe like an enterprise thing, maybe some database, Kafka queues or Kafka brokers, and you may require them to run your app, right? So you know there is like a lengthy process where you build your app locally, then you have to deploy somewhere to be able to figure out what's happening. So like this, you can just have your Quarkus app running on your Kubernetes cluster, and you can just use the services that are there to help you develop, and have instant feedback on things. So that's the dev mode, and that's usually what people enjoy from Quarkus, or one of the things that people enjoy from Quarkus. Now I'm going to run Quarkus dev again, and the next thing I'm going to show you is our continuous testing feature. So continuous testing allows you to run the tests that are related with the code that you change. Right, so this is not active by default because at first start we have to run all the tests, and that may be a little bit lengthy. So we don't want for you to have to run the tests all the time when you start up the server. But if you hit R, so there on the console, you'll see now starting tests, and then running tests, and now you'll see here on the bottom of the screen you'll see all one test is passing, one test was run. So everything seems to be fine. Now let's look into some of the tests, right? So I have here this test, which is, it's calling numbers resource generate number, and then it's trying to assert here the format somehow of the number that's being generated, right? So you'll notice there is like a dash, right? So you also notice that on generate number, there's like a prefix, and there is like a numeric part, which is separated by that dash. So let's change that to a plus, right? And if I go to my terminal again, now you notice I haven't done anything, and Quarkus just, he realized that that test is related with the code that I just changed. So it executes the test for me, and just saying, the code that you changed is not passing the test anymore, so it failed and gives you an error. So this is really interesting because it gives you instant feedback about things that you're changing, right? Of course, if I come back to my code and change that to a dash again, and go to my terminal, now you already see, one test is passing, and everything is fine again. Now you don't have to, I only have this test, I can probably add a couple of more, but this is actually a really cool side effect of us collecting so much information from compilation time and the build phase. So we know exactly which tests are in the project, and we know how are these related to the code. So we only actually execute the tests that are related with the code that you change. So we don't, every time you change a piece of code, we don't run all the tests, just the tests that are affected by that code change. Right? So that's pretty useful. Okay, so now I'm going to move to Book API. So that's another service that I have here on this presentation or this example. And this is a more complete application, right? So if I show you here a couple of classes of the code, so let me put that over like that. You'll see there are a bunch of endpoints over here. To create updates, so there's going to create update books. Here you can find the Open API stuff. Let me put a little bit bigger. So you see there's a bunch of endpoints now. You're also going to find a book repository. So there's a couple of queries over there. So it is a more complete application. But what you'll notice over here is, there is a database involved, right? Because there is a repository over here. It's using Entity Manager, it's using JPA and Hibernate. So you're definitely going to require a database to be able to run the app, right? And you may be thinking, well, now I need to either start up my own database, or maybe someone gives me a Docker Compose file, or I have to connect to some enterprise database to be able to run the app. So let's try to run Quarkus in demo and see what happens. So now I'm starting Quarkus again, and I'm starting this on Book API. And now you'll notice that it's going to take a little bit longer to start, but actually what you'll see over here is Quarkus notices that there is no database to connect to. So because there is no database that is able to connect, it's going to start one for you using either Docker or Podman, right? So if I come over here and say docker ps -- all, now you'll see there is like a Postgres running over there. There's also a Kafka broker that's being executed, because the application that I wrote also requires a Kafka broker, right? So if you look here on the logs, you'll see you even see things like flyway being executed to migrate the schema of the database. So in this particular line, you see database Postgres started on over there. It's even called Quarkus, and here you see the Kafka processor being executed, right? So now I don't even need to connect to external services. I can just like clone the app and just hit Quarkus dev, and Quarkus is going to start all the other services for me automatically, without me having to care about what I need. If I close the app, and if I go to docker ps, now you'll see there is no Postgres, or there's other things that I have, right? But Postgres is not there anymore. And also the Kafka broker is gone, right? So when Quarkus is killed, we just remove all of the other containers, and they're gone. Now, this is what we call dev services, and there are a bunch of other aspects around that, right? So of course we set up some defaults that you can use. Or I mean, for instance, for the Postgres one, of course we generate or we use a default image. But you can override that and use your own image for Postgres. Maybe you already have some database with some initial data that you want to use. So you can override the images that are being used to start these services. In the case where you actually don't have either Docker or Postman, you could actually run this using Test Containers Cloud, which is going to bootstrap all these containers in the cloud for you, which is also super cool. So this is what we call dev services, and usually people also love these a lot. So let's go over here, and okay, so everything is fine. I still have things running on Kubernetes. Let me just kill that. So let's go, because I want to run number resource locally again, but I don't want the Kubernetes version. Just something that I should have told you when I was running that example is, if you go here and target Kubernetes, you also see that Quarkus generated the Kubernetes deployment file for you, right? So you can use that. So I'm going to use that to just remove the services. So kubectl delete f target Kubernetes YAML, and now they're gone. Great. Okay, so the last thing I want to show, well, not the last thing, but the other thing I want to show you is, let's see, I think I have that here. Yep. So I'm going to unshelf here, and remember that I told you that you could even write Quarkus applications with Spring. So I'm just going to unshelf this, and I'm not going to write that because I don't remember the APIs by memory. But I was a Spring user in the past, so I love Spring. I think that these guys have done an amazing job with Spring. That's why we also wanted to have a way to support their API, so people that are coming from Spring, they don't have to learn a new thing. So let me just comment this for now, because I want to show you something later. So let's do it like that. Hello. So now you're seeing this is similar, this is recognizable for you, right? So this is for people that are coming from Spring. You'll see Spring Framework annotations. So this is a typical controller for Spring using request control and request mapping. Now, let's start Quarkus in dev mode again. And let's see if that actually works. So, starting up. And I have request mapping is on /greeting. So let's say curl and say greeting. Then you get it, you got hello, right? And if I change these, you get the exact same developer experience that I was showing you earlier, but now with Spring code, right? Which is super cool. Now, there is one interesting side effect I want to show you that, well, this is sometimes you get these errors with Spring. But now, what I'm doing over here is I auto-wired here a beam, right? So I can just say, instead of hard coding the string over there, I can call, say hello, and you see this an interface, right? So I have to implement that. But the point is I don't have an implementation. So what happens when I don't have an implementation? This not only happens with Spring, but even other runtimes, right? So usually this is what I call the ticking time bombs, which is, well, you start up the application, when someone calls that code, it's going to blow up because it's not able to find an implementation to call or to inject over there. Now, let's see what happens with Quarkus. So I'm going to do a compilation, right? So this is what you usually do with one of those runtimes, and I mean that's completely valid code. It should compile, right? And while doing the compilation, let's see what happens. A little bit slow because of, I mean, the QuickTime thing is just taking away a lot of my resources. But now notice that what you got over here is a build failure, right? So it means, well, uncertified resolution exception is not able to find the greeting implementation to inject. Now, because we do a lot of the things on build time, we're actually able to have a lot of the things that will blow up or give exceptions at runtime now be compile time exceptions, which allows you to have or to write safer applications or to have applications with less issues, right? So this is also a really interesting side effect of having Quarkus, or I mean, it doesn't have to be Quarkus because there are other runtimes that are doing similar things now, but having a runtime that does a lot of build time optimizations. Okay, so the last thing I want to show to you is native image. So let's roll back this, and now I'm going to say ambient, well, let's say clean package native. And this is probably going to take a long time, especially because, well, QuickTime is taking a lot of my resources. But what native does now is I'm going to build Quarkus, the application as native, right? And if you, as I mentioned earlier, if you have like a C background, or if you know anything about C, or if you have to compile a C application before, you know this is a lengthy process, right? So while I'm not building a C application here, what's happening is something very similar on what we're doing with the C compilation, right? So now it needs to analyze the app. It needs to pretty much do all the conversions to the native execute that's going to be executed, right? There's a lot of initialization code that's being executed beforehand to optimize the thing. So there's a bunch of operations happening, right? And as you can see, I'm trying just to entertain you, talking to you, until I wait for this to actually happen. So it's getting there, a little bit slow, but it will get there, hopefully. So it still misses like a few steps. But anyway, the goal when you're running native is not for you to be part of your regular development process. So one of the things that we will try to do with Quarkus is we give you the exact same experience between the native mode and the JVM mode, which I was running with Quarkus Dev, or you can even run that with java-jar. So the idea here is you'll build and you develop your app using JVM, and then you can just build it as native. I mean, everyone should have a continuous integration environment, or at least a build environment, and then you can just tell the build environment to do that for you, so you don't have to build the native image all the time. And you just do it, well, after you integrated your code or whatever, if you want to use the native image. Yeah, so still going. So usually when I'm not recording, this takes like a minute, but I guess that we are like in a 2 or 3 minutes mark. But we are mostly done, hopefully. So it's already on the last step, and yeah, and there you go. So it took like 2.5 minutes, and now I'm going to do a target, an LMLS target, and you'll see there is a number API run over here, which is only 61 meg. And I'm going to do something that you should never do, right? Never do this, please. I'm going to cut that. Now you see there's a lot of garbage over there. I guess that you believe me that this is a completely binary file. And how do you run these files? So, well, you do it like /, right? And now you run it, and now you see it was super fast, right? So if you notice over here, it took like only 59 milliseconds to start. So let me do that again. Boom, right? So you see again, 58 milliseconds over there. And well, I can call curl. Not that one, because that doesn't exist anymore. I removed that. So now you have, of course, what the app is actually supposed to do. But if I go to my monitor, well, this is not Java anymore. This is not the JVM anymore, right? So you can search for this now by number API runner, because that's the binary that you executed, right? And if you look into memory, now you'll see, well, there's only 25 megs of memory that's being occupied by that process. So, which I believe that's impressive. So that's the promises that I made to you with Quarkus at the beginning of the presentation, and I hope that I was able to fulfill those expectations. So that was the last thing I wanted to show you. So the only thing that I have left is to thank you for watching this presentation, this session, and I hope that we can see each other again anytime soon. So again, thank you so much for watching. Here's some resources, and enjoy. Bye-bye.